Good morning to you all. One more class today on drawing. The topic is projections of planes. In the previous two topics, projections of points, projections of lines 1, projections of lines 2. After that, a plane object, two-dimensional object, negligible thickness, plane objects, square, rectangle, polygons, all are coming in this group. Today's topic is projections of planes. Let's observe the type of planes. Plane object, all constructions are following any one shape. Any object, take an example of any object, it should be a shape, all coming to this group. Square shape, rectangular in shape, triangular in shape, hexagonal, that we call polygons, pentagon, hexagon, heptagon. So these are all polygons will come into this group. Again, a circular in shape, circles, semicircles. Today class I discuss about a plane in first quadrant. Take an example of a plane. How that plane, say for example take a plane. This is the plane object. So negligible thickness plane. Say this plane how in this reference plane. Similar to projections of lines 1, plane also located in the first quadrant, maybe parallel to both HP and parallel to one plane, perpendicular to other plane, parallel to other plane, perpendicular to both the planes. No, these conditions I am going to discuss today class. How the plane is specified in the first quadrant. What I am going to tell today, type of planes, classified according to this group. Mostly we related polygons only, hexagon, pentagon and circle related problems are available in this sheet. Planes perpendicular to, let us observe first, perpendicular to one plane and parallel to other plane. Let us observe. So consider a plane. How this plane in the first quadrant, perpendicular to horizontal plane, parallel to vertical plane, perpendicular to horizontal plane, parallel to vertical plane. Front view gives the true shape of this object. Say 4 corner points are there. Front view gives the true shape. When a plane parallel to which reference plane, on that plane we will get the true shape. How this plane? Parallel to VP. In VP we can get the true length. In HP only a line will come. Only line will come. So in the front view a plane, top view a line of the position of this plane. Now this is the plane, these are all the reference planes. How this plane? Plane is perpendicular to HP, parallel to VP. Front view is the true shape of a square and top is a line. This is the one. A line perpendicular to one or parallel to other. No. What I assumed first one, perpendicular to HP. Similar manner, say perpendicular to VP parallel to HP. Perpendicular to VP parallel to HP. Top view gives true length of the true shape of the object. Front view give a line. Front view line, it is because it is perpendicular. Perpendicular to VP, front view gives the line, top view gives the true shape of an object. So this is about the first case. Line perpendicular to HP, perpendicular to VP. Now perpendicular to both the planes. Second condition is perpendicular to both the planes. Let's see that this is a typical condition. So number of times we ask, show a model a plane perpendicular to both the planes. Let observe. Perpendicular to both the planes. Say perpendicular to HP, perpendicular to VP. Perpendicular to HP, perpendicular to VP. Front view is a line, top view also a line. One question may ask in the examination, both the front view, top views are lines. Specify the plane. Specify the plane. Plane perpendicular to both the reference planes. That is the answer. Both front view is a line, top view also line. When these two lines will come? When a plane is perpendicular to both the reference planes, that condition will come. Both front view is a line, top view is a line. So this is a plane perpendicular to both HP and VP. Front view is the line, top view also line. See the last one. A plane inclined to HP parallel to HP perpendicular to VP. Now a perpendicular to one plane and inclined to other plane. Perpendicular to, let observe this one. Observe. So perpendicular to one plane, inclined to other plane. So perpendicular to HP. So this is the inclined to HP. Inclined to HP perpendicular to VP. Inclined to HP perpendicular to VP. Front view is the line. Top view is reduced in shape because of this inclination. Because of this inclination, top view become a reduced, front view become right. Listen carefully. This type of problems are solved in two stages. This type of problems are solved in two stages. Clear? So we will cover in the next 2 or 3 slides. Now first these are all the conditions. Line inclined to HP perpendicular to VP, or line inclined to VP perpendicular to HP. Line inclined to VP perpendicular to HP. So these are all the conditions. A line, a plane like this one, parallel to one, perpendicular to other. Line perpendicular to both. Line inclined to one and perpendicular to other. So these conditions, let me discuss one by one. Let observe the condition. Now 2 examples are given here. It is. Now take example, a triangular in shape. How this triangle is positioned in the first quadrant with respect to these reference planes. Now this is the horizontal plane, this is the vertical plane. How this triangular plane is in the planes? So a triangular plane is parallel to VP perpendicular to HP. A triangular plane parallel to VP perpendicular to HP. Top view is a line. Top view is a line. Front view is the true shape of a triangle. True shape of a triangle. First draw the true shape of the triangle, then project from the front view to top view. So that is the length of the remaining side. Length of the remaining side. Say, let's see. Now, triangle. What is the condition? Parallel to VP. Parallel to VP. On VP we can get the true length. True shape. Top view, a line because perpendicular. Let observe the one more. The model, that is a square is given. How oriented this square? Parallel to horizontal plane. Parallel to horizontal plane, perpendicular to vertical plane. Perpendicular, parallel to horizontal plane. On horizontal plane we get true shape of an object, say ABCD. ABCD is the top view. A top view, B top view, C top view. So this is the shape equal to the shape of the object. So front view is a line. Now this is the first condition. What is inclined? So parallel to one, parallel to VP, parallel to HP. Let's see the other condition. See this condition. Plane perpendicular to both the reference planes. Observe the square plane. Observe the square plane. One more question may ask. A plane perpendicular to both the reference plane, which view give the true shape of an object? Side view gives the true shape of an object. Now these two views are, one is the front view, one is the top view. In side view, you can get the true shape of an object. Let observe, while looking from the other side, we can get the true shape. But in the front view and the top view, only lines are available. This is the critical question asked a number of times. Both front view, top view are lines. What is the position? A plane perpendicular to both HP and VP. Now this is the condition. Front view is a line, top view also a line. Now this is the other condition. Let's see the one more condition is there. Now these are all the good conditions. A line or a plane inclined to horizontal plane, perpendicular to vertical plane. Now let us observe this one. So other side I am going to take like this one. Inclined to horizontal plane, perpendicular to vertical plane. Now what is the important points need to tell in this point? Such type of problems are solved in two stages. This type of problems are solved in two stages. Such type of problems are solved in two stages. First stage, assume the plane parallel to that reference plane, parallel to HP, draw front view and top view. So parallel to HP, first draw front view, top view. First parallel to HP, first draw front view, top view. For example, XY line. Now this is right. A, B, C, D. Its front view. A dash, B dash, C dash, D dash. Then tilt the required inclination. So in the second stage, tilt the required inclination. While tilting, the front view doesn't change. So this is the front view. So that means, so let observe, this is the front view, this is the top view. So this is the front view. While tilting in the second position, its front view doesn't change, only the required inclination will change. So tilt the front view, tilt this line at an angle 30 degrees. Copy that existing measurement. So this is C dash, D dash, A dash, B dash. Then project A and B. From A to horizontal line, A1, B to horizontal line, B1, and C and D. C to horizontal line, C1, D to horizontal line, D1. This is the final object. This way you can solve n number of problems. Any type of problems can solve. These two steps need to implement. What are the two steps? First, assume the plane according to the given condition. What is problem says? A plane 30 degrees to HP. First assume parallel to HP. Draw the simple position. First condition. Parallel to HP means top is the true shape, front view is the line. Then tilt that line, front view tilted. So front view tilted without changing. The line tilted according to the required angle. That line is tilted according to the required angle. So draw that line at a required angle, then project, we can get the final shape, reduced shape of the object. Shape because this is the reduced shape. Because of this inclination, this is the reduced shape of the equal to reduced shape. This way you can solve n number of problems. Let's observe this one. Now another way, incline to VP. So for example, take a board, incline to VP. inclined to VP. Say this is the inclination. This is the inclination. How we can solve this one? So for example, I am assuming this is the vertical plane, this is the horizontal plane. Now say this is the vertical plane. This boat is vertical plane. Now how this one? So incline. This is the inclination. This is the inclination. Incline to VP. What I told in the previous, 2 steps are required. First step, don't consider this inclination. Don't consider this inclination. First assume parallel to VP. Parallel to VP. Parallel to VP means front view is the square. Parallel to VP, front view is the rectangle. A dash, B dash, C dash, D dash. Top view is the line. A, B, C, D. So this is the top view, this is the front view. Let observe, this is the top view, this is the front view. So I am tilting the required inclination. Tilting the required inclination. Let observe, while tilting the required inclination, this line also tilted required inclination without changing this value. Without changing this previous, what is the previous value? This is the previous value. Just while tilting. Now, tilt this line at an angle by the side. Any gap, any convenient gap, draw this line at an angle 40 degrees. What is the length of the line? That length of the line you have to copy this length. Copy this length. Copy this length. Copy here. Now, name it all the points. A, B, C, D. Project. A, B are there. Where is the A? From A to horizontal line. From A to horizontal line. Say this is the A1. A1 dash. Say again B. B to horizontal line. B1 dash. C and D. C to horizontal line. C1 dash. D to horizontal line. D1 dash. Now this is your required shape. Now that is the final shape of this is the final shape of this object. So initially take it an example of problems, and based upon this one a problem sheet is designed. Just concentrate the problems on this one. Very simple problems. These problems I will solve in the next class. Only go to concentrate on theory part. Next class I will solve all these problems. I will forward to your mail. Only theory part I covered today. So go through this particular theory part, read 1 or 2 times, then we will discuss the problems in the next class. Now till today I covered these concepts. Go through these concepts, prepare well, see you in the next class. In the next class I will solve these problems, and as well as I will start one more topic, that is a solid. Tomorrow class I will solid parts I will go to start. Till today just concentrate on this one, only theory part. We will meet you again in the next class. Thank you for the listening.
These are all the general plane surfaces and the methods of construction. Now, let us discuss about the position of a plane in the first angle projection. Before getting to the topic, let us recall first angle and third angle projections. If the object is placed between the observer and plane, it is called as first angle projection. Whereas, if the plane is placed between the object and observer, then it is in the third angle projection. While considering these two projections, first angle projections are more commonly used as they are easier to understand than third angle projections. Before heading into the traces of plane surfaces, we will see what a trace is. Any of the plane surfaces has extended, if necessary, will meet the reference planes in lines unless it is parallel to any one of them. These lines are called as traces of the plane surfaces. The traces of plane surfaces have been categorized into 4 types. They are 1. Perpendicular to one plane and parallel to the other. 2. Perpendicular to both the planes. 3. Perpendicular to one plane and inclined to the other plane. 4. Inclined to both the planes. perpendicular to one plane and parallel to the other. Consider any plane surface, for instance a square lamina that is placed in parallel to the horizontal plane HP and which is perpendicular to the vertical plane VP. As it is parallel to HP, the original position will be appearing only in the top view. Hence, the top view will have the regular square and the front view will have the straight line as shown here. The square lamina is placed perpendicular to the horizontal plane HP and it is also parallel to the vertical plane VP. As it is perpendicular to HP, the original position will be appearing only in the front view. Hence, the front view will have the regular square and the top view will have the straight line as shown here, perpendicular to both the planes. When the plane is perpendicular to both the vertical and horizontal planes, the front and top views will have only the straight line. In this case, the side view only shows its original position. Perpendicular to one plane and inclined to the other plane. Consider the square plane which is perpendicular to the vertical plane and parallel to the horizontal plane. If the plane is perpendicular to VP and inclined to HP, then the position of the plane will be as shown on the screen. As the plane is perpendicular to the vertical plane, the apparent view will be appearing on the top view, inclined to both the planes. Now, let us discuss the projection of plane inclined to both VP and HP. Consider a square lamina that is inclined to the horizontal plane. The top and front view projections of square lamina will be present here. When the plane is also inclined to the vertical plane, the top and front view projections of the square lamina will be as shown on the screen.
What is a plane? A geometry which has two dimensions is called as plane. In this, the third dimension is negligible. Sometimes it is also called as planar geometry. Examples are triangular plane, rectangular plane, pentagonal plane, hexagonal plane, and so on. We can also have a semicircular plate or a circle as an example of this. Now, the examples mentioned here are also called as polygons because they have multiple sides. Let us discuss a few triangular planes. Triangular plane can be of different shapes. First is this one, the second one, the third, and the fourth. Now, here the first one is called as equilateral triangle, where all the three sides are equal and the included angle is same, that is 60 degree. Second one is right angle triangle. Third is isosceles. Isosceles means there are two sides which are same. So these are the two sides which are same. And this is a scalene triangle where you have all three sides different. So the most important note here is a geometry for which at least two dimensions should be specified is called as two-dimensional geometry. Means at least I'm using the word here because for these three cases two dimensions are sufficient to describe them, but in case of scalene you need all the three sides which are different. Moving forward, cases of projection of planes. Based on how the plane is positioned, there are different cases which are as follows. Case 1. Surface of plane is parallel to one reference plane and perpendicular to another reference plane. Now the solution will consist of a single stage in this case. Case 2. Surface of plane is inclined to one reference plane and perpendicular to another. Now the solution for this case will be having two stages. Case 3. Now this is the most preferred case in examination. Surface of plane is inclined to one reference plane and reference, that is it may be a side, edge or diagonal etc., which is given to us, is inclined to another reference plane. Now it consists of three stages. Now we are talking about three front views and three top views. This is the most asked type of questions in examination. In today's video we will discuss the case number 1. Now in order to go to case 3 you need to understand case 1 and case 2 very well. So let's start with the case 1. Surface of plane is parallel to one reference plane and perpendicular to another. Here we have two subcases. A. Surface of plane is parallel to HP and perpendicular to VP. Whereas we have B case such as surface of plane is parallel to VP and perpendicular to HP. Now let us take an example. Before that, let us see the procedure. For case 1, what should be the first step? Draw the first view in which the true shape is visible. So while starting with the solution, draw that view first in which the true shape of the plane is visible. It can be front view, it can be top view. Second step, draw the opposite view. Means if you have drawn front view as your first step, now draw the top view. And if you have drawn the top view first, then now draw the front view. Now sub case 1, if surface of plane is parallel to HP and perpendicular to VP. In order to understand it better, let us take an example. A rectangular plane PQRS with side PQ is equals to 60 mm and QR equals to 30 mm has its surface parallel to HP such that its side PQ is parallel to VP and 20 mm in front of VP. Also the surface is 45 mm above HP. Draw the projections of the plane. So we have a surface parallel to HP here, it is perpendicular to VP. So this is our example for this case. Now we are talking about this plane PQRS, the blue one. Here PQ is mentioned as 60 and QR is mentioned as 30 mm. So QR and PS both are 30, PQ and RS are 60. Now here it is being said that PQ is parallel and 20 mm in front. So this is PQ, this is parallel to VP and it is 20 mm in front of it. Now as we can see, the true shape, that is the surface having this plane, this surface will be visible in top view. So this is how you get the rectangle of true shape in the top view. So for this example we have to draw the top view first. So let's draw the solution. This is the XY line, the first step. Take a projector, take distance equal to 20 mm, then draw a line 60 mm long parallel to XY. Then take this PS equals to QR equals to 30 mm and complete the rectangle. Once you finish with the top view, move towards the front view after naming this top view P, Q, R and S. Now the distance. The plane is 45 mm above HP, so the front view will be 45 mm above XY line. Take a projector and this is your front view. Naming it, you will have 2 points here. One is P dash and one will be S dash. Then other side we will be having Q dash and R dash. So this is the top view and this is the front view. Now important note, when the surface is parallel to HP, then the true shape of the plane is visible in top view. So in this case, step number 1 will be top view will be drawn as first step, and step number 2, front view, will be the second step of the solution. Second subcase, that is B, if surface of the plane is parallel to VP and perpendicular to HP. Taking this as an example, changing the names now. A rectangular plane ABCD with side AB equals to 70 mm and BC equals to 40 mm has its surface parallel to VP such that its side CD is parallel to HP and 20 mm above HP. Also the surface is 35 mm in front of VP. Draw the projections of the plane. As we can see, this is the question of similar type, that is in first quadrant. We have this rectangular plane. The difference is here the surface is parallel to VP. In earlier question the surface was parallel to HP. So this is the blue plane we are talking about, A, B, C, D, and these are the two views we have obtained. As we can see here, the true shape, the rectangle, is visible in the front view. So for this case, the first step will be front view. So let's draw the solution. This is an XY line. Then we have the first projector. Then taking the distance equals to 20 mm, because here it is said that CD is 20 mm above HP. Naming this point as D dash. Drawing a line which will be equal to the given distance AB equals to 70 mm. Then taking the width, that is the breadth of the rectangle, equals to 40 mm, completing the rectangle. Naming it A dash, B dash, C dash and D dash. Once you finish with the front view, we'll take the top view. The distance is given as 35 mm in front, so this will be 35, then completing it. So naming it, we'll have 2 points here, A and D, and here we'll have V and C. So this is the front view and this is the top view. Important note here, when the surface is parallel to VP, then the true shape of the plane is visible in front view. So for this case, front view will be the first step and top view will be the second step. Now this was all about your case number 1.
Hi friends, welcome back. Let's start with the session for the projections of planes, where plane is a two-dimensional graphic element having length, width and negligible thickness. Based upon orientation, planes are classified as perpendicular planes having their surface perpendicular to one of the reference planes and parallel or inclined to the other reference plane. Second is an oblique plane having their surfaces inclined to both reference planes. Now, let's study the projection of a plane ABCD, which is perpendicular to HP and parallel to VP. Observe the diagram carefully. The projector lines from C and D extended through A and B meets the HP in points DA and CB respectively. The lines DA, CB is the top view and the horizontal trace HT of the object. Since the plane is parallel to VP, there will be no vertical trace of the object. This is the visualization of a projection in three-dimensional space. So now we will proceed with actual drawing on paper. First, draw a horizontal reference line XY. Then draw a rectangle A dash, B dash, C dash, D dash of the same size as ABCD above the line XY on VP at a height of H units. This is a front view. Then draw a horizontal line DACB at a height of D units below and parallel to line XY, which is the top view. Now consider another case where the plane ABCD is located in the first quadrant as its surface is inclined at angle theta to VP and perpendicular to HP. As we can see, the front view is A dash, B dash, C dash, D dash and the top view is DACB. Let's illustrate its construction in detail. For this, first locate point DA below the reference line XY at D1 units. Measure an angle theta and locate point CB at D2 units. Then draw a line DACP. From these points, draw vertical lines to meet XY and extend them further for a distance of H units to get points A' and B'. Next, extend it further, locating points D' and C'. Observe, by joining all these points, we'll be getting the front view as A', B', C', D'. Now, what will be the construction of projection when rectangular plane surface is inclined at an angle of 60 degrees with the HP and 30 degrees with the VP? For this, let's go through the steps. First, the plane is assumed to be parallel to HP with its longer edge perpendicular to VP. Then, observe the diagram for step 1. The true shape and size of the plane is given by its projection on HP. The front view will be a true line parallel to reference line XY. Next, in step 2, rotate the front view projection by angle of 60 degrees. Draw vertical lines from points A', B' and D', C' to intersect horizontal lines drawn from the top view of step 1 ABCD at points B1, C1, D1 and A1. A1, B1, C1, D1 is the top view of the plane when inclined at 60 degrees with HP. Now, rotate the edge B1, C1 of the top view by angle of 30 degrees as step 3. Draw projections from A1, B1, C1 and D1 to intersect the horizontal projections from D', C' and A', B' to get the points A2', B2', C2' and D2'. Observe, A2', B2', C2', D2' is the final front view of the given plane surface when inclined 30 degrees with the VP. And that's it.